Welcome viewers, in this video we will see the formula to remember for sets, relation and function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, important formula to be remember. First one is De Morgan's law. That is the sets, relation and function. De Morgan's law, first one is A union B dash equal to A dash intersect B dash, right? The De Morgan's theorem, here union means here intersection. Here whole bar available, here bar available individually. A union B dash equal to A dash intersect B dash. Similarly, A intersect B equal to A dash union B dash, right? Both are differ. Here intersect mean union, here union mean intersect. A divided by B union C equal to A divided by B intersect B divided by A divided by C, right? That is nothing but A divided by B, A divided by C. Here union, here intersect, right? A divided by B union C is nothing but A divided by B intersect A divided by C, right? Then A divided by B intersect C is nothing but A divided by B union A divided by C, right? So it is very simple. Here union means intersect means union means intersect means union, right? Like that we have 4 De Morgan's theorem available. Using that we can solve the problem. Then reflective. A relates A, small a, for all A belongs to capital A. So this is a subset, this is a main set, right? So A relates A for all A, small a, subset relates to the main set, right? Then we'll go to the remaining. Symmetry. Next one is the symmetry. A relates B implies B relates A for all A comma B belongs to A, right? Symmetric means A relates to B, B relates to A, right? That's a symmetry. A to B, B to A also same. For all A to B belongs to capital A, right? These two are subset, that is belongs to the main set A. Then transitive. A relates B, comma B relates C implies A relates C for all A, B, C belongs to capital A, belongs to the main set, right? So here A to B, B to C, here A to C, right? So the transitive, this transitive, A to B, B to C implies A to C, right? Here if we are going from A to B, B to C, so that A to C also available for all A, B, C belongs to the main function, main set A. Then anti-symmetric. We already discussed symmetric, now anti-symmetric. A relates B and B relates A such that implies A equal to B for all A comma B belongs to capital A, right? So this is a anti-symmetric, right? A relates B and B relates A implies A equal to B. That is A difference, A symmetric B equal to A divided by B union B divided by A. That is the meaning of anti-symmetric, right? A symmetric B equal to A divided by B union B divided by A, right? We have another 2 more functions available. We'll see that. 1 function. 1 function. If function f such that A relates to A goes to A, then function f of x1 equal to function f of x2 implies x1 equal to x2 for all x1, x2 belongs to main set A, right? That is a 1-to-1 function. The function f is available, A implies to A. Then f of x1 equal to f of x2 implies x1 equal to x2 for all x1, x2 is belongs to A. Then onto function. Codomain equal to range. If a set has n elements, then the total number of subset is 2 to the power n. So onto function is, it will give the n elements available in the set, means the subset having total number of subset will be 2 to the power n, right? So in this video we discuss the important formula for sets relation function. First discuss the De Morgan's theorem. There are 4 law available. De Morgan's theorem. A union B dash equal to A dash intersect B dash. A intersect B equal to A dash union B dash. A divided by B union C means A divided by B intersect A divided by C. A divided by B intersect C means A divided by B union A divided by C. Right? This side union means that side intersect. Then reflective theorem, reflective, symmetric, transitive, antisymmetric, one-to-one function and onto function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.